Hey guys, here's a video connecting factoring, quadratic formula, solutions, imaginary numbers, irrational numbers, a lot of good concepts into one video. So let's start by considering the different ways a quadratic can dip below the x-axis or above. So you can have it dip in a really nice way where you have nice, happy, rational numbers like 2 and 4. Or you could have it dip in a way where you get some really strange irrational numbers like negative square root of 7 and positive square root of 7. It can also just barely touch at one point, or it could not touch at all. And each of these are going to have different ways of factoring them. If it dips at 2 and 4, we can write this as x minus 2, x minus 4. If it dips here, that's going to be x minus negative square root of 7, x minus square root of 7. And we can write that as x plus square root of 7, x minus square root of 7. And if it touches at one point, that's going to be x minus 3, x minus 3. It's called a double root. And finally, if it doesn't dip at all, well, then we really don't know how to factor it. In fact, we cannot factor it. The factorization would be something imaginary. So x plus something I, x minus I, and it might be a 3i and a 3i or a 2i and a 2i, where we just can't tell from the graph. So those are the four different possibilities. You can have nice, happy integers. You can have irrational numbers. You can have a double root, or you can have imaginary. So let's take a look at equations and see what we can do with them. So let's start with something like this, and we'll see which of those cases it is. So x squared plus 6x plus 8. And we can factor this out. And if we factor this out, we get x plus 4, x plus 2. But let's pretend for a second that we didn't know how to factor it. Let's consider this. We're going to solve this, find the solution using the quadratic formula. When we set this equation equal to 0, we're asking ourselves what value of x makes the y value 0, and what other y value of x makes the y value 0. So we're considering that problem. So to solve that problem, we're going to use the quadratic formula. So again, our equation is x squared plus 6x plus 8. And the quadratic formula has these letters in it. And let's identify what our a, b, and c are. Our a is 1, it's invisible, we'll draw it in there. Our b is 6, and our c is 8. So now I'm going to go in, I'm going to erase each of these guys, and we're going to plug in these things in parentheses. So we'll plug that in. All right. Now when we simplify this out, it's going to be negative 6 plus or minus the square root of 36 minus 32 over 2. And that's going to further simplify to negative 6 plus or minus the square root of 4 over 2, which is going to be negative 6 plus or minus 2 over 2, which is going to turn into these different possibilities: negative 6 plus 2 over 2, negative 6 minus 2 over 2, and that's going to turn into negative 4 over 2, which is negative 2, and that's going to turn into negative 8 over 2, negative 4. So we have those two solutions, negative 2, negative 4. So let's go back up here. Our two solutions are negative 2, because negative 2 makes a 0, and negative 4. So those are the two solutions. Now that we know what the solutions are, we're going to flip those signs, and with that minus 4, we're going to do x minus minus 4, x minus minus 2, and of course that just turns into x plus 4, x plus 2. So what we just did, in a very, very roundabout way, is we found that the factorization of x squared plus 6x plus 8 is x plus 4, x plus 2. And we did that by using the quadratic formula and going through all that work. And you're probably wondering, why are we going to all that work when we can just look at this and say, two numbers that multiply to be 8 that add up to be 6 are 4 and 2. And the reason I'm going to this much effort is to consider the second case. Remember, the first case is where you have nice happy integers like 2 and 4. The second case is where you have irrational numbers. And when you have irrational numbers, it's a case where you're not going to be able to see how to factor this. So consider this equation. X squared plus 6x plus 1. Let's say we wanted to factor it, and we know because it's a second degree polynomial, we should have two factors. So we're looking for numbers that multiply to be 1 that add up to 6, and you can obviously tell that's not going to happen. So it could be the case, we don't know right now, it could be the case that the reason it can't be factored is because it's one of these ones where it's floating above. That might be the case, or maybe the reason we can't factor is it's because it's a couple of irrational numbers. So let's go ahead and use the quadratic formula and see which of those cases it is. So we're going to set this thing, just like we did, we're going to set this thing equal to 0, and we're going to use the quadratic formula. All right, and I'm just kind of zipping through this kind of fast. That's going to be 36 minus 4. And that's going to be negative 6 plus or minus the square root of 32 over 2. And I'm not going to walk through this simplifying the square root, but just take my word for it that the square root of 32 is 4 square roots of 2. And that's going to turn into negative 3 plus or minus 2 square roots of 2. So that means that the two solutions are, on the one hand, negative 3 minus 2 square roots of 2, and the other hand, negative 3 plus 2 square roots of 2. So on a graph, if this is a graph, this is the one solution, negative 3 plus 2 square roots of 2. This is negative 3 minus 2 square roots of 2. So how does that answer the question? What we're trying to do, again, is we're trying to factor something like this. What was it? X squared plus 6x plus 1. So x squared plus 6x plus 1. And I'm looking for numbers that multiply to be 1 that add up to be 6, and what we have are the two solutions. So how do we take those two solutions and put it into something that's factored? Well, let's go up and look at our previous example, up above somewhere right here. Let's see, right here. Okay, in this one, our intercepts were at negative 4 and negative 2. Because the intercepts were negative 4 and negative 2, we flipped those signs, and it's 4 and 2. So we have that sign flipping. So we're going to do the same thing, and right here, we're going to say x minus negative 3 minus 2 square roots of 2, and x minus negative 3 plus 2 square roots of 2. And that is how you factor that. Let's clean that up a little bit. X plus 3 plus 2 square roots of 2, and x plus 3 minus 2 square roots of 2. And these numbers, if you added them up together, that one plus that one, those numbers would add up to be 6. And if you multiplied them, they would also multiply to be 1. And if you don't believe me, let's just try this and see what happens. If we multiply this out, 3 and 3 is 9. That's going to be minus 6 square roots of 2. And then right here, that's going to be plus 6 square roots of 2. And then this is going to be minus 2 square roots of 2 times 2 square roots of 2. Let's clean this up. Those guys cancel. 9 minus 2 and 2 make 4. What's the square root of 2 times the square root of 2? The square root of 2 times the square root of 2 is actually just going to turn into 2. So it's 9 minus 8, which is 1. So those numbers, which is 3 plus 2 square roots of 2, 3 minus 2 square roots of 2, those are the numbers that multiply to be 1 and add up to be 6. And the only reason we see that is from the quadratic formula. Okay, so just to recap, in case you're confused, here's the idea. If you have something like this, x squared plus 6x plus 8, and you want to factor it, one way of doing that is setting this equal to 0, using the quadratic formula, and when you do that, you're going to get negative 4 and negative 2 as your solutions. On a graph, they would look like this, negative 4, negative 2. So when I write this in factored form, it's going to be x plus 4, x plus 2. I flip that negative 4 to positive 4, flip that negative 2 to positive 2. Now, let's look at this one. the one that we just did, is x squared plus 6x plus 1. And when we use the quadratic formula, we end up with 3 plus 2 square roots of 2, 3 minus 2 square roots of 2, actually negative 3. And so when we write this in the factored form, it's x minus negative 3 plus 2 square roots of 2, x plus negative 3 plus 2 square roots of 2. So it just looks horrible, but it is the same process. Now, we've talked about the first case. Let's go back up to our graph. There we go. We've talked about the first case, nice happy integers. We've talked about the second case, irrationals. What does the third case look like? What's that going to look like in the quadratic formula? So let's do this one. Let's do x squared plus 6x plus 9. And we can factor this. And when we factor this, we get x plus 3, x plus 3. And so we're done. Now, if you wanted to use the quadratic formula, let's just do this really fast. Negative 6 plus or minus 6 squared minus 4ac all over 2a is going to be negative 6 plus or minus 36 minus 36. And that's going to be negative 6 plus or minus square root of 0. Square root of 0 is 0. And so that's just going to give you negative 3 as a solution. Because negative 3 is a solution, that's going to turn into positive 3. Okay, now we've talked about 3 different cases. We have nice happy integers like 4 and 7. We have weird square root type things. We have this. Now what's it going to look like if it doesn't have any intercepts at all? Let's do something kind of absurd. Let's do like x squared plus 6x plus 9. That's what we just had. It's this, it touches at one point, but instead of 9, what if instead of adding 9 to this, we just make this something huge like 100, and it's going to go super, super high, and let's just see what that looks like. So if we put this in the quadratic formula, we're going to have negative 6 plus or minus b squared minus 4ac all over 2a. And that's going to be negative 6 plus or minus 36 minus 400 all over 2. And that's going to be negative 6 plus or minus the square root of negative 364 over 2. And when we have a negative under a square root, that's going to pop out the letter I. Now you might be able to simplify this square root a bit, but I'm not going to. What we can do now is we can consider those two solutions, negative 6 plus I square root through 364 over 2, and negative 6 minus I square root of 364 over 2. And we're going to put this now in our factored form. It's going to be x minus, it's always x minus, okay? Because again, we're flipping the signs. Just in case you're not sure about the x minus, let me show you this example. Let's say you have 2 and 3. You're going to write x minus 2, x minus 3. The positives flip to a negative. If those were minuses, it would be minus minus. Okay, so you're okay flipping signs? Good. We'll just keep that to a minus. And so now we're going to do, in parentheses, both of those things. Negative 6 plus I square root of 364 over 2. And this one is going to be negative 6 minus I square root of 364 over 2. And now you have this equation in factored form. Okay, so everything can be factored, but if it looks like this, and it's like 3 and 7, then the factored form is really nice and happy. If it is like this, and it's some weird decimal, it could be a nice rational number, like a half or a third, or it could be some kind of thing like x plus 3 square roots of 7, x minus 3 square roots of 7, something like that. If you have something like this, then then you have 2 solutions, but they're identical. So this is in a case where it goes through 3. And if you have something like this, it's going to have i's in it. It might be x plus I, x minus 3i, or some combination of i's and square roots, but something a little bit gnarly. Okay, that is everything you need to know about irrational, rational, graphing, solutions, and the quadratic formula.